Okay, graphing a parabola by hand. You should be able to graph a parabola. Now, you do have the use of your graphing calculator, and that's always there for you to use. But sometimes we don't always have it with us. And parabolas really aren't too bad to graph by hand, as long as you know, again, they're not super complex in these cases. And so we're going to practice graphing by hand. You can always check on your calculator. Once we graph by hand, we should be able, in order to graph by hand, we have to determine the vertex, axis of symmetry, and how it opens, right? Whether it has a max or minimum value. And so again, we're going to graph by hand, meaning without the calculator. All right, so first example. F of x is 4 minus x squared. Alright, so the first thing is always, it's kind of like finding the slope first in a line. Find the vertex. So remember, the vertex is my x value, and the vertex is the opposite of b over 2a. Well, remember, ax squared plus bx equals c. Not equals c. Bx plus c equals my function. In this case, a is negative 1, right? There's a negative front in front of my x squared. There is no x term. Well, that's fine. That means my b value is 0. If it doesn't exist, it's 0. Right? So my b value is 0. And so in this case, when I plug in 0, opposite of 0 over 2 times negative 1, I can divide into 0. I just can't divide by 0. And so my vertex happens to be at the x equals 0, which is nice. It means it's going to be on my y-axis. And then I find the y value by plugging 0 in. When I plug 0 in, I get 4. And so my vertex is at the point 0, 4. Since a is negative, I know it's going to open down. Alright, now, when we draw a parabola by hand, now lines, you need at least 2 points to graph a line. When you graph a parabola, you need at least 3 points. You need the vertex and a point on each side of the vertex. And so I need 2 more points. Right, to fill out my table, so to speak. And you want points on both sides of the vertex so I get the right shape. And so usually we pick the same. So x0 is where my vertex was, and so I want to pick values on both sides of 0. So I need a positive x value and I need a negative x value. Well, I'm just going to pick positive 1 and negative 1. Right, because those are on both sides of my vertex. So when I have positive 1, well, my y value is when I plug 1 into my function. And so when I plug 1 into my function, it's going to be 4 minus 1 squared, which comes out 3. And so 1 point is 1, 3. And then when I plug negative 1 in, f of negative 1, well, I'm going to get the same thing, right? 4 minus negative 1 squared comes out positive 1. And so it's going to be 4 minus 1, so it's going to come out 3 again. Again, that has to do with the symmetry, right? That should happen because of symmetry. And so negative 1, 3 is on the other side because of symmetry. And so when I go to graph it, I'm going to use those 3 points. All right, so graphing it. That's my x. There's my y. All right, so I'm graphing my vertex first. So vertex was at 0, 4. So 0, 4 puts me here on my y-axis. So there's the vertex. 0, 4, which, again, should be my maximum because it's opening down. And then I pick points on each side of it, right? 1, 3 puts me here. There's my 1, 3. Negative 1, 3 puts me here. Negative 1, 3. And now I've got my graph. And again, because I picked points on both sides, I get the right shape out. And so there's f of x. Okay, make sure I find everything that I was asked to find. I found the vertex, max and min. Haven't found the axis of symmetry yet. Alright, so this would be the maximum. Would be the y value 4. Alright, that's the maximum, y value 4. And so my axis of symmetry goes through that, and so it is the y-axis, right? My axis of symmetry is the y-axis, which is a special type of vertical line. It's the line x equals 0, right? It goes through the point x equals 0 would be my axis of symmetry. those 2 points, if I fold them over, would hit each other, right? They're at the same place on the opposite side of my axes of symmetry. And it would work out the same way. If I found 2 and -2, they would be on opposite sides and the same distance away from my axes of symmetry, right? These are the same distance away. If I picked -2 and +2, it would behave the same way. That's what it means to be on the axis of symmetry. All right, so when we're graphing, we find the vertex and a point on each side of my vertex to make sure that I get the symmetry right, and the graph comes out to the proper shape. Alright, so let's do another example. I'm going to erase so I give myself a little more room here. Alright, so a second example. Graphing by hand without the calculator. You can always check your answer on the calculator if you want to. So my second example would be the function g of x equals 0.5x squared minus 2x plus 2. So again, I know it's going to open up because of the positive 0.5. Alright, find your vertex first. So the x value on the vertex is the opposite of b over 2a. Well, b was a -2, so opposite of -2. You can just put 2 down if you want to. Over 2a, a was my 0.5, and then simplify that, so that comes out to be -2, +2 over 1, comes out +2. Alright, so my x value is at +2. My y value, well, I plugged 2 into my equation, so I go back up here and plug 2 into it. Alright, when I plug 2 in, it actually comes out 0. Alright, so my vertex is on the x-axis. X equals 0, y equals 2. And I know it opens up, which means this is a minimum at x, at y equals 0, right? That's my minimum. I actually know what my axis of symmetry is too. It's this x value. Axis of symmetry is x equals 2, right? It's the x value through my vertex. Which means I need 2 more points to get a good graph of this. And so I pick a point on both sides of the tube. And usually I just go 1 point away. Alright, so I need 2 more points to graph. And we pick the 2 points on both sides of my vertex. So my vertex is at 2. And so I'm going to pick it on the smaller than side, x is 1. And on the bigger than side. You can pick any value you want. Just the best way is, though, to pick them the same distance away. So 1 is 1 unit away from 2. 3 is 1 unit away from 2. I just find those are the easiest points, but you could pick any other 2 points on the other side. If you go 2 points away, you'd go to 0 and 4. If you pick 0 and 4, that's fine too. Alright, so I need my y value that goes with 1, so I take 1, plug it into my function. So I'm going to go back up here and I put f instead of g. So I'm just going to change this to f since I do f on my whole problem. Alright, so I'm plugging it back into the 0.5 1 squared minus 2 1 squared. So it comes out, my 2's cancel out, so it comes out 1/2 0.5. Alright, and then I should get the same thing when I plug 3 in. Based on symmetry, it should put it at the same place. But check that it is. Plug 3 into this equation and see that you do get a positive 1/2 out. And you do. It comes out 0.5. Alright, so when I go to graph it, erase this here to give me room to graph it. Those are the 3 points I'm going to use to graph it by hand. There's my x, there's my y-axis. So I know it hits it right here on my y-axis. That's my vertex 0, 2, and that's my minimum, right? Because it opens up. My next point was at 3.5, right? 3.5 puts me about right here. That would be 3.5. And my other point is at 1.5. And there's my 1.5. And again, they're the same distance apart. My axes of symmetry is x equals 2, right? So those show up the same distance away on each other side of my axis. So I've got the right shape then. So then I draw my parabola. And it opens up. And it's a wider one, right? It should be a bit wider than the last example because I multiplied by 1/2 out front. And there's the graph of my function by hand. Alright, which then you can check on the calculator. You should be able to do it both ways. You should be able to graph by hand and on the calculator. Alright, so there was examples. Graphing by hand.